Okay, people, let's get started here. We have got a quiz coming up, and so here is a recap of all the things you should be able to do at this point. First of all, is this point on the graph? Well, a point is an x comma a y. So what I will do is take the f of x function, I will plug 0 into the function, and then I will see if 1/2 is the output for the y. 0 minus 1 is -1. 0 plus 2 is 2. I'm noticing that it's not a positive 1/2, it's a negative 1/2, and so the answer would be no. Make sure you label your work with what you're plugging in. F of what? If you're plugging a number in, you must say so. For part B, it says if x is 2. Okay, so they want me to now plug in the number 2. F of a 2 is 2 minus 1, 1. 2 plus 2, 4. F of 2 is 1/4. What point is on the graph? Well, the point 2, comma 1/4. When 2 goes in, 1/4 comes out. Okay, so writing a point as an x and a y, and this would be function notation. Part C is a little different because it says if f of x is 3. So now they're saying 3 is the output, what is the input? Okay, so 3 isn't going to go into the f of x spot, into the y spot. And do you remember how to handle this? You have to put the number 1 underneath that, and then we have to cross multiply. So crossing this way gives us the quantity x minus 1. Then you write equal signs, then you cross the other way. Biggest mistake people will make is they say 3x plus 2. No, the 3 has to get distributed to the quantity, so don't forget to give it to the 2 and make a 6. See, I'll subtract 1, get 2x this way. Subtract 6, get 7, so x is -7/2. So what is x? That is x. What point is on the graph? Okay, the point is -7/2, comma 3. Don't forget to put the x first and the y second. All right, what are the x-intercepts? Very similar to what we just did. To find an x-intercept, you let y equal 0. So 0 goes into the y spot, and we're going to solve for the x. Again, put a 1 down there, and we're going to cross multiply. Quantity times 1 is just that quantity. Equal sign, 0 times the whole quantity makes a 0, and x is a 1. Don't forget, intercepts are points, so make sure you write 1, 0 on the answer line. Okay, so there's some algebra type questions with function notation. Here is a picture of a graph, and I could ask you questions about the graph. I notice this graph goes down, down, down this way, up, up, up that way. Maybe what I'll do is exaggerate the graph just so that I'm clear how it goes off the graph paper a little bit. I don't see any holes or any asymptotes. What is the domain? The smallest x value is going to be -infinity. The graph goes and goes and goes all the way to +infinity. If you don't like to write that, you can write all reals. Range, smallest y value is -infinity. The graph goes down, down, down. The graph definitely uses all the negatives. Definitely uses all the positives, even though it goes up and down. Again, all reals or double bar R. Okay, intercepts are points where the graph touches the axis. So I see a couple of them. Here's an x-intercept at the point -4, 0. And here's a y-intercept at the point 0, 2. We got a couple different intercepts, x and y's. How often does the line y equal 2 intersect the graph? Okay, that's a HOI. That's a horizontal line. So here it is, horizontal line intersecting the graph 1, 2, 3 times. 3 times. How often? If it said where, I might have to say all the places. But it just said how many times. Okay. What does f of 4 equal? 4 is the x value. Let's see what comes out. 1, 2, 3, 4. And the point right there at 4, 3. So f of 4 is a 3. And the last one, this is the fun one that we always like. For what values of x is the graph greater than 0? So should I cover up the stuff that's less? This is what I always do. Cover it up, only let people see the graph that's greater. Now, since it says greater, we do not want to equal 0. You're not allowed to equal. You're only allowed to be more, more, more. Oh, all of this is greater. All this is greater. Then it goes up, up, up forever. So this whole section is greater than 0. I'm going to use interval notation starting at the point -4. Since it's greater, that's an open bubble. I'll have to use parentheses all the way to infinity. Okay? All right, please be ready to answer some questions if I give you a graph. Let's do some calculations and talk about domain a little bit here. F divided by G. I have to take the F function and divide by the G function. That's a lot of functions there. I think what I'm going to do is go old school. F divided by G, and they're both of variable x. So I'm going to write the F function like this, and then I'm going to say divide by the G function like that. And using my fraction knowledge from dividing, I'm going to change that to multiply and reciprocate the second one. So the first one is still the square root of 2x minus 4. And then we have a 3. Then we're going to change to multiply, flip it around to 8 over 5x. Can I cancel any numbers? Numbers with numbers? No. These are inner radicals, so they don't even get to be looked at. You can't cancel those x's. This is a whole quantity. You can't take the 4 out of the radical because, again, he's a quantity. So we're just going to leave this as 8 times the square root of 2x minus 4. I put the 8 in front so it doesn't look like it's 48 or he gets under there. Put it out in front. These denominators I will multiply to say 15x. So that's F divided by G of x. And it says state the domain. Okay, for domain, we want to look everywhere. We want to look in the beginning, we want to look in the middle, we want to look at the end. So looking at F, this numerator has some domain. 2x minus 4 has to be greater than or equal to 0. And if we solve that, that says x has to be greater than or equal to a 2. G has no problems. I look here. I've already got that radical taken care of. These are just numbers. Oh, but wait a minute. Look right here. X suddenly goes into the denominator. So I don't want to use 0. X cannot equal 0. And I've got all these guys. So let's take a look at all of our pieces and state the overall domain. X has to be more than or equal to a 2 for that radical to work. Should I say do not be a 0? I don't really need to state that because when I say use numbers like 2, 3, 4, I don't plan on using numbers like 0. So you don't have to state that because that would be redundant. Okay, something else that we studied was even, odd, or neither. And the way that you algebraically calculate this is you do f of negative x. So let's plug in negative x using some good parentheses here into the equation. And then you simplify it and see what you get. So f of negative x is, let's see, since it's an odd power, negative x to the 5th. That's going to make an odd power negative times negative. That's going to make plus 2x cubed. Don't forget to give the cube power to the x, plus 7. So is this the same? Is it the original? Nope. Is it the opposite? Nope. This one would be considered neither. Neither. Okay, part B. Let's calculate f of negative x. So negative x has to get squared, and then there's plus another negative x minus 1. Let's do the simplifying. Make sure you label your work. Don't just plug in a negative x without telling me you're plugging in a negative x. Nice work here, people. X squared minus x minus 1. Is it the same? Almost. Is it the opposite? Almost. This is another neither. So look at all the terms carefully. And the last one, f of negative x. So 5 times negative x upstairs. Downstairs we're going to have our negative x get squared, so that's going to turn him positive. So the denominator is 2x squared plus 1. and that's going to be a negative 5x. But remember what I said to do? If you get a negative, let's write it out in front. Negative, put the 5x. So here's a fraction, but I noticed that this fraction is the same as the original problem, except this fraction is negative. This fraction and this fraction are opposites. So since they're opposites, this one is odd. Therefore, odd. Oh, let's just be fancy and use the symbol for therefore, neither. Based on my calculations, it is therefore neither. Okay, something else you should be able to do is state intervals. Okay, and the key to getting these is remember you're always going to use x values. All right, I'm looking at this interesting graph. The graph starts at the point, goes down, 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 down to like right there, and then up, 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 up. So this section right here is decreasing, and then this section right here is increasing. And that's the only two sections this graph has. There are no constant sections. Okay, so I'm just going to say none or cross it off. If you leave it blank, I might think you don't know what you're talking about. Increasing starts here. X value is negative 3. Remember why I always use brackets? I don't want to make a hole there. It increases from there to there. That x value is 2. If it helps you to see the coordinates 2, 4, so you grab the right value, the x value, from negative 3 to 2, that's a closed bubble, so bracket it up. The decreasing section goes from here, brackets negative 5, all the way to there. X value again is negative 3. If you were to put these together, all your sections, that should make the entire domain. Here's the domain going up, here's the domain going down. There's no domain for constant. All together, that makes all the x's for the graph. That way you know you didn't miss anything. Okay, make sure you study everything in your packet up until the point where we're going to quiz. The next thing we're going to talk about quickly is composing functions. And composing functions means that you're going to put a function into a function. Okay? Put a function into a function. You're not putting a value into a function or a variable. You're putting another function in. Okay, let me show this cute little picture. Here is a little bite of food. I'm going to call it X. I can't wait to see your pictures. And here comes this big fish. Okay, here's this big fish. I'm going to call this fish G. He's going to eat the little bite of food X. G is going to eat X. But, I didn't tell you this, there's this even bigger fish with really scary teeth. Look at those teeth. This big fish, okay, is going to eat this little fish. And the little fish eats the food. This big fish is called F. So what's happening here? F is eating G, but G is eating X. Is F eating the food directly? No. The food is not going into the F fish. The food is going into the G fish, and the G fish is going into F. And that's what I mean by put a function into a function. Your variable X only goes into one thing. Here's the notation. This says F of G of X. So that is not a time sign. It's not a dot. That means of. There's another way to write this. Okay, kind of like my picture here. This says F of. Now what is F of? F is of G, which is of X. I prefer this notation a lot because it's very clear that the little fish is G, the big fish is F. And instead of fish, we're going to start saying function. So how does this work? Okay, today we're just going to do numbers. F of X and G of X. And we're asked to find the following. So I have to find, I'm going to write this a better way, F of G of a 1. So what we need to do first is calculate the inside. So please write equal sign, and please write an F. Now, the 1 is going to go into the g function. So look at your g function here. And we have to put 1 into that. So g of a 1 is 4 times 1. Answer is 4. But we're not done yet. But you need to show me this intermediate step. Now, 4, even though it was the answer, becomes the input. 4 goes into the f function. So take this f function right here and tell me what 4 squared times 2 minus 3 is. 29. Okay? And if you want to be good at labeling, this is f of g of 1. Okay? At no point do you say g of 1. You nest them all together like that. Let's do another one. This problem here says g of f of 1. Well, is that answer just the same as this answer? Let's go see. So first, you're going to write the big function, and you're going to do the little calculation inside. Let's put 1 into f. 2 times 1 minus 3 is negative 1. Now, negative 1 has to go into the g function, and the output is negative 4. Do you see how after I do the f function, I just write the answer? You don't write f anymore. And after you do the g calculation, you just write the answer. Okay, so you have to be clear with your letters. After you calculate, you don't write it, but you need to label every step. So this is the answer for g of f of 1. Okay, this is kind of a weird question, but yes, it can be done. Can you do f of negative 2? Can you do the same function twice? Yes. You just have to do it twice. So first write the outer f. Let's take negative 2 and place it into the function. Negative 2 squared. 4 times 2 is 8, minus 3 is a 5. And now we're not done. Now that answer has to go back into f. 5 squared, 25, times 2 is 50, minus 3, 47. So yes, you could do a function of a function all day long. Okay. The next one is evaluating with a table instead of using equations. So here's your x, there's your input. The f function answers are right there. So what's f of a negative 3? If negative 3 goes into f, the answer is negative 7. If negative 3 goes into a g, the answer is 8. So your input is at the top, and then your answer for either f or g is right there. So again, let's work on our notation. I don't like this because it's not as clear. So let's all write f of g of a 1. Okay, so what do we have to do here? First, we have to take 1, plug it into g, and find the answer. So the top row is your input. So here's 1. And the g function is the answer right at the bottom. So g of a 1, the answer is 0. Okay, now we have to do f of 0. So let's start back at the top because my input is now a 0. But I have to put that into the f function. The f function answer is negative 1. I know it's kind of weird. Once you get the hang of this, it goes really fast. Let's try a couple of more. Let's try f of g of negative 2. Okay, so first write equals, write your f with some big parentheses because we're going to calculate the inside first. If you take negative 2 as your input and you plug it into the g function is the bottom, answer is 3. So right here I could see your work. I could see what happened when you plugged it into g, but now we have to plug 3 into the f function. So let's find 3 as the input. The f function for 3, the answer is a 5. 5. All right, let's try C. G of f of negative 1. Okay, so write the g function because we'll do the inside one first. what's negative 1 into the f function? The top row has your inputs. Negative 1 into f says negative 3. Now we're not done because that answer becomes the input into the g function. So if negative 3 goes into g, the answer is 8. Starting to get the hang of this? Okay, the last one is a double function. It's g of negative 2. So let's put negative 2 into the g function. Get yourself all set up here for the answer spot. Negative 2 into g is a 3. But now 3 has to go into g, and we get 8. Okay, we could also do the same kind of work by getting our answers off of a graph. Okay, so our same notation here. This says g of f of negative 1. Okay, so first thing you have to do is find f of a negative 1. So look at this picture. This absolute value light graph, the stick one right here, that is the f function. And this curvy one up here is the g function. So if I put negative 1 into f, I'm looking for the point, negative 1. And what's the output? What's the y? A 1. That's a 1, but we're not done. Now take 1 and look at the g function. G function is the curvy one. Find the point 1 and tell me the output. The answer is 4. Okay, hopefully your notation's going good from all the practice up on top. Now we just have to work on looking at the graph to find the answer. G of f of 0. So the first thing we're going to do here is get all set up. We have to plug 0 into f. Okay, so look at the f function. It's kind of weird, but it's right here. It's the point 0, 0. So 0 goes in, 0 comes out. And we're not done, because now 0 has to go into the g function. And this one again is kind of weird, but the point is right there on the y-axis. It's the point 0, 5. So when 0 goes in, 5 comes out. Okay, guys, we're almost there. Part C, f of g of negative 1. Okay, so first let's write f of, look at the g function first, find negative 1, and the y value is 3. Now we're not done. Put 3 into the f function. Where is it? It's right here. That's the point 3, negative 1. Oh, the answer is negative 1. I can't wait to see all your work for this part right here tomorrow in class, and I want to see what you get. I can't wait to see it.